So right now we're going to try to describe square roots. Okay, so first let's start off with the definition. So definition. This is the definition of the positive square root. Okay, so let B be a non-zero real number. So all we're saying here is that B is greater than or equal to 0. The square root of B is a number A such that A times A equals B. A times itself equals B. We denote the solution to this equation by A equals the square root of B. So this is just the way that we write the solution of this equation. We put this radical and then we put the number B on the, in this case, on the right hand side. So the square root of B is another way of just writing this solution A. So let's have an example. Example. 4, so x squared equals 4. So we have to determine what x is. Well, let's break down 4 into its factors. 4 is just 2 times 2. So we have 2 times itself equals 4. So 2 times 2 equals 4. So the square root of 4 is 2. So because 2 multiplied with itself gives us 4, we call 2 the square root of 4. Okay, let's do another example. X squared equals 25. Okay, so we break down 25 into its factors, which is just 5 and 5. So 5 times 5 is 25. Therefore, the square root of 25 is 5. Because of this right here, because 5 times itself is 25, we call the square root of 25 5. Okay, let's do some more examples. Okay, what do I want to do? Continued. So x squared equals 784. Okay, so we have to see if we can split this guy into one number times itself becoming 784. Let's see if we can do that. Let's draw our tree. 784. 784, well, I know 4 divides into it. 4 times 196 is 784. Let's break down this 196. That is 4 times 49. Let's break down this 49. That is just 7 times 7. So we can write 4 times 4. So 4 times 4 times 7 times 7 is 784. Okay, But because the only thing happening between each of these factors over here is multiplication, it doesn't matter the order that we multiply two numbers. So I'm going to regroup these things. What I'm going to do is I'm going to switch this 4 with this 7. So 4 times 7 times 4 times 7 equals 784. 4 times 7 is 28. So it's 128 times another 28 is 784. So we have one object, one number, times itself being 784. So therefore, I'm going to come down here and rewrite it. I'll write it right here. So therefore, we can say that the square root of 784 is 28, because 28 times itself is 784. 28 times itself is 784. Okay, so this process that we've been doing, where we create this little structure that gives us all the factors of 784, let's look at something. So this is called a tree, a factor tree, because, well, if you turn it upside down, I guess people think that this is like the base of the tree, and these are branches, and then there are, leaves and forks and all these things. So they call it a tree, but like an upside down tree. The things at the very end of the tree, so 4, 4, 7, and 7 are called leaves, kind of like how the leaves are the very end of a tree. So what we see here is we notice pairs in our leaves. So there's a pair of 4s and a pair of 7s. So essentially what we're seeing is that we take a pair from the 4, or we take one number from this pair of 4s, and we take one number from this pair of 7s, and then that will give us our answer. Because this is all the leaves here, all the leaves here, we take a pair out of each one, and that gives us our answer to what is the square root of 784. All right, let's have another example. Okay. So we have, let's do 900. X squared equals 900. Okay, so let's go on the side, and we're going to make our factor tree out of 900. That is 9 and 100. 9 times 100 is 900. 9 breaks down into 3 times 3. 100 breaks down into 10 and 10. So we're going to circle our pairs in the leaves, and we're going to pull out a number from each pair. So we're going to pull out a 3, and we're going to pull out a 10, and that becomes 30. So we're going to check to see if this really is the square root of 900. The way we check it is we go, okay, well, when I multiply this guy with itself, I better get 900. 30 times 30 actually does multiply to be 900, so we'll check it over here. 0 times everything is just 0. Carry down 1. 3 times 0 is 0. 3 times 3 is 9. So this is indeed 900. Okay? So therefore we can write 30 is the square root of 900. Right? This is the only thing we're doing with square roots. We're just getting a pair. For every pair in the leaves, we're pulling out one number from the pair. Okay? Okay. All right. So now let's try a different number. So x squared equals 8. Okay? X squared equals 8. Well, same thing. We just break our 8 down. We break our 8 down. This becomes 2 times 4. We can break our 4 down. That's a 2 times a 2. Okay, so we have one pair of leaves, but then we have this 2 by itself. So here we can say that 8 is 2 times 2 times 2. We're going to bring these two guys together. 2 squared, and 2. Now, it would be really nice if we had a number. I'm going to call it alpha. It would be really nice if we had a number alpha such that alpha times itself equals this 2. Okay, if this were the case, then we could write 8 equals 2 squared times alpha squared being the 2 here. This guy multiplies to be 2. And we could regroup, and we could get 2 alpha times 2 alpha. Okay? And then we could say that 2 alpha is the square root of 8. But off the top of my head, I don't know of any number that I can multiply with itself to get 2, right? So let's have it as a side problem. So we are hunting a number alpha such that alpha times itself becomes 2. All right? Now, what do we have? So let's just try plugging and chugging. So we're going to make a table of perfect squares. So let's have a 1, 2, 3, 4, 5, 6, 7, 8. Didn't need to be that long, but that's okay. So here's our number n. Here is n squared. Okay? So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 36, 7 times 7 is 49, 8 times 8 is 64. Okay, so if we're hunting a number alpha such that when I multiply it with itself I get 2, it's going to be between 1 and 2. So let me show you. So we have 1 times 1 is 1. We have 2 times 2 is 4, which is too big. 4 is bigger than 2. So our number alpha can't be above 2. It has to be between 1 and 2. So let's give that as a fact. Alpha has to be between 1 and 2. Or alpha is less than 2, greater than 1. Okay? So let's try another number. 1 plus something. So 1.4. Okay? If I get 1.4, so alpha, so here's what we're trying. Try alpha is 1.4. This leads us to alpha times alpha is 1.4 times 1.4, which is equal to, what is that equal to? 1.96. 1.96. Okay, that's not bad. That's pretty close to 2. It's not 2 exactly. It's like 400ths off. But let's try 1.5 and see if we can get a better approximation. So try alpha equals 1.5. That leads us to 1.5 times 1.5. 1.5 times 1.5 is 2.25, which is too big, right? 1.5 times itself is a number bigger than 2, and we need it to be 2. Okay? So this does not work. Okay? So 1.4 seems to be our best approximation so far. Let's go further. So let's try alpha is 1.4. I'll do 3. 4, 3. So then we have 1.43 times 1.43, 43 times 1.43. This is 2.0449, which is too big. So this doesn't work. Because even though we're not over 2 by much, we're only over 2 by 449 tens, hundreds, thousands. So we're only over it by 449 10,000ths. But tens, hundreds, thousands. Yeah, we're only over it by 449 10,000ths. But that's still over it. Won't work for us. Let's try alpha is 1.42. What do we get? 1.42 times 1.42 is what? 1.42 times 1.42. Nope. 1.42 times 1.42. That is 2.0164, which is too big. Let's try alpha is 1.41. 1.41 times 1.41. 0.41 times 1.41. Aha! So this is 1.9881, which is even closer to 2. It's somewhere around 200ths away from 2. Okay, so that's a better approximation. So our first good approximation was 1.4. Our second good approximation was 1.41. Okay, let's keep hunting. So we got our best approximation so far. Best approx so far is alpha is 1.41. Okay. So let's keep going. Let's keep going. So 1.41. Let's try alpha equals 1.415. Okay. So 1.415. So this goes that way. Times 1.415. 1.415 times 1.415. Too big. It's like 2.002, and then there's some more stuff, ... which is too big. Won't work. Let's try alpha equals 1.414. So alpha is 1.414. 0.414 times 1.414. That is equal to 1.999396. Okay? So we're getting closer and closer. Every time we find the next best approximation, we're getting closer and closer to 2. 1.999 is really close to 2. Okay? So we can continue this process forever. So we can continue this process forever. It's actually called the Babylonian method. And it is around 3,800 years old. Okay, so this is something discovered by the world's very first civilization. I think this is like Sumerian. The Sumerians knew about this long time ago. Okay, their approximation that they got was they got alpha. I think, what did they round off at? They rounded off they got 1 plus they got 1 plus 24 out of 60 plus 51 out of 3,600 plus 10 out of 216,000. Okay, they used a base 60 number system, so what this winds up being very close to in our decimal system, in our base 10 system, is I think it is, so they got it's approximately equal to 1.414213. Okay, which is pretty good. I think whenever you square this, so with this guy, they got alpha times alpha is 1.999998. Approximately that. Whenever you square this thing, this is about what you'll get, which is pretty close to 2. Pretty close. Okay? But remember what I said, we can continue on with this process forever. It would never stop. We can keep on finding a better and better decimal approximation. Okay? So what we do, instead of writing it out as a decimal forever, we just write the number that satisfies this equation. The number that satisfies this equation is alpha equals the square root of 2. We just call it this thing. We just go, okay, there's some number out there, this thing, which is approximately 1.4, such that when I multiply this object with itself, I get 2. And we just call it the square root of 2. There's really no better way to write it than this thing. I mean, maybe if you're familiar with other notations, people call it 2 to the 1/2 power. It's the same thing, but we're just going to use this radical for the time being. So we just call alpha equals the square root of 2. So let's go back to our problem. We were interested in x times x equals 8, or we were interested in finding the square root of 8. What is this thing? What number multiplies with itself to be 8? So on our tree, of 8, so we had 8, that's an 8, 8, that factored into 2 times 4 and 2, 2. We circle our pair of leaves, and we have 8 is equal to 2 times 2, so from this pair, times another 2. We're going to break down this 2 at the tail into its square roots. So 2 times the square root of 2 times the square root of 2. That's what this guy broke down into. He broke down into both of these numbers right there. Square root of 2, from our definition, the square root of 2 times the square root of 2 is just 2. It's just 2. This is the number out there that multiplies with itself to become 2. So now, what I'm going to do is I'm going to regroup, rewrite and regroup. So we're going to have, switch these two in the middle, 2 times the square root of 2 times 2 times the square root of 2. Okay, and now we have one number, this thing, multiplied with itself that gives me 8. So that must mean that the square root of 8 is 2 times the square root of 2. Okay? 2 times the square root of 2. Okay? So let's check and see if this actually holds up. So we're going to take this guy and multiply him with itself and just work our way back up this chain. Okay? So 2 times the square root of 2 multiplied with itself. Okay? Because the only thing happening between all these four numbers is multiplication, we're going to regroup. We're going to associate these whole numbers, this 2 and that 2, and we're going to associate these square root numbers, square root of 2 and square root of 2. So 2 times 2 times the square root of 2 times the square root of 2. 2 times 2 is 4. The square root of 2 times the square root of 2 is just 2. Let me say it again. This number has the unique property that when I multiply it with itself, I get 2. So I multiplied this object with itself, and I got 2. 4 times 2 is 8, and that's what we needed. So this works. Okay? Let's see if I have some more examples. Okay. All right, so we'll do 48. So find a number out there such that when we square it, we get 48. Well, if we look back at our table of perfect squares earlier, excuse me. So 7 times 7 is 49, but 8 times 8 is 64, so both those are too big. And 6 times 6 is 36, so looks like it's not a perfect square, so it's going to be an irrational number. It's going to have, when we simplify it, it's going to have a square root in there, a square root symbol. So this isn't a perfect square, so it's going to be an irrational number. It's going to have one of those square roots on there. So 48 is 6 times 8. 6 is 2 times 3. 8 is 2 times 4. And then 4 is 2 times 2. So here, let's look at our leaves. We've got a pair of 2's there, a pair of 2's there, but a lonely 3. So let's have it like this. So 48 is 2 times 2 times 2 times 2 times 3. Or 2 times 2 times 2 times 2 times the square root of 3. 2 times 2 times 2 times 2, 1, 2, 3, 4, times 3. Okay, so we've got some repeated patterns going on here. A pair of 2's with a 2 multiplied with itself, a 2 multiplied with itself, and then we've got this 3. So we're going to break him down into his square root. 2 times 2 times 2 times 2 times the square root of 3 times the square root of 3. Okay? So we're going to regroup these things. 2 times 2 times the square root of 3. 2 times 2 times the square root of 3. So I kept a pair of 2's together here. I kept a pair of 2's together here. So these 2's are together, these 2's are together, and I moved around the square roots of 3. So that must mean that, what does this simplify to? 2 times 2 is 4 times the square root of 3. 4 times the square root of 3. So I have one object multiplied with itself that gives me 48. So the square root of 48 must be 4 times the square root of 3. Okay? Let's check. So check. 4. When I square this guy, I better get 48. 4 times the square root of 3 times 4 times the square root of 3. 4 times 4 is 16. We've got our square roots of 3 still. Square root of 3 times the square root of 3 is just 3. 16 times 3, what is that? That's 30 plus 18, which is 48. So that works. Okay. Let's do another example. Actually, let's do that same problem, but a different way. So x squared is 48. 48. So if I just recognize that 48 is 4 times 12, and then I recognize that 12 is 4 times 3, I could just stop here. I don't have to break it down all the way. I could just say, okay, well, this isn't completely factored. I can group these two guys together and then just come out with x, pull a pair out of the 4s. The 3 is by itself, so he goes into the radical as the square root of 3. And then I could check. So when we just did that, x squared is 4 square roots of 3 times 4 square roots of 3. 4 times 4 is 16. Square root of 3 times the square root of 3 is 3. 16 times 3 is 48. Okay? So, okay. Let's see if I have any more. 56. So what number multiplies with itself to give me 56? Okay, so we have 56 is 7 times 8. We have 8 is 2 times 4, which is 2 times 2. Okay, so this is the tree of 56. The pair here, we have a lone 7 and a lone 2. So we write 56 equals 2 times 2 times 2 times 7, okay? Which is just, I'm going to bring this guy. So 2 times 2 times 14. 14, which is just the 2 and the 7, doesn't have a perfect or is not a perfect square. So it just breaks down as the square root of 14 times the square root of 14. Okay, I'm going to regroup because order doesn't matter when multiplication. Okay, so then we have 56 equals, the square root of 56 is 2 times the square root of 14, or x equals 2 times the square root of 14. If we multiplied this thing with itself, and we use the definition of the square root of 14, we would get 56. So if we multiplied this guy with itself, like up here, we would get this thing times itself is 56. All right. We could have also have kept 56 equals 2 times 2 times 2 times 7. We could have broken up these two numbers into their square roots. We would have gotten 2 times 2 times the square root of 2 times the square root of 2 times the square root of 7 times the square root of 7, which is just, once we regroup, 2 times the square root of 2 times the square root of 7 times 2 times the square root of 2 times the square root of 7. Okay, so what do we have there? So 56 equals 2 times the square root of 2 times the square root of 7. 2 times the square root of 2 times the square root of 7. So therefore, the square root of 56 is just one from this pair. So it's just 2 times the square root of 2 times the square root of 7. But we also got the square root of 56 is 2 times the square root of 14. So this wound up working. Let's see if this works. So we'll go down here and we'll write check. We're checking to see if this guy works. So 2 times the square root of 2 times the square root of 7 squared. We're seeing if this thing is equal to 56. That's why I wrote the question mark. We don't know yet. So 2 square roots of 2 square root of 7. 2 square root of 2 square root of 7. Okay, that's the left-hand side. 2 times 2 is, actually I'm going to regroup this. So 2 times 2 times the square root of 2 times the square root of 2 times the square root of 7 times the square root of 7. 2 times 2 is 4. The square root of 2 times the square root of 2 is just 2. The square root of 7 times the square root of 7 is just 7. 4 times 2 is 8 times 7, and that is 56. So we have two different ways of writing the same number. 2 square root of 2 times the square root of 7 is the same thing as 2 times the square root of 14. Okay? Typically, whenever we're writing, none of these are incorrect, right? Like if I'm not grading your tests, but if I were to grade tests, I would give you credit for this because it's the same thing as this guy over here, but typically we like to write, I guess just by convention and tradition, we like to write our answers with as few radicals as possible. So this guy, we would just write it like this. So whenever you're writing your answer, if you get lonely guys like this, square root of 2 and the square root of 7, you can just combine the insides. So what I'm trying to say, I guess, although I haven't proved it, the square root of a times b is I guess this is actually written in the reverse way. The square root of a times the square root of b. So from left to right, the square root of a times the square root of b is just the square root of a times b. They're both inside of here. Okay? All right. Maybe we'll do... Do I have another one? Let's do, I think it's the square root of 30. So the square root of, I think, 1800? Yeah, I think that's the one I want to do. Okay, so we're going to find a number that multiplies with itself. In other words, we're looking for a number that multiplies with itself to become 1800. All right? So 1800 is 2 times 900. 2 times 9 is 18, and then the 2 zeros just carry on. 900 is 9 times 100. We also did this problem earlier. this guy. What's the square root of 900? 9 is 3 and 3. 10 is 10, or 100 is 10 and 10. Okay, so x equals, we're going to pull out a 3 from this pair and a 10 from that pair. So a 3 times a 10. This guy is just by his lonesome. So we just write a square root of 2, which is equal to 30 times the square root of 2. Okay, so let's check to see if this works. So check. So 30 times the square root of 2 times 30 times the square root of 2. So that's x squared. 30 times 30, square root of 2 times the square root of 2. 30 times 30 is 900. Square root of 2 times the square root of 2 is 2. So this is 1800. Okay, so that worked. Right? The way that you always check yourself is you take the number that you found and you multiply it with itself. And you better get what's inside that radical up here. Okay? So I think that's all I wanted to cover. Hopefully this helps you understand and simplify square roots a little bit more. At least, hopefully it helps you get more comfortable working with them. All right. Thanks, guys.